glucose level climbs, what happens? The pancreas releases insulin, and it pushes that glucose into cells. If you have type 1 diabetes, a condition in which your immune system destroys those beta cells, then you don't have the insulin available to push glucose into cells. And so you develop severe hyperglycemia. Right? Glucagon is just the opposite. Glucagon release is stimulated by hypoglycemia, conditions in which glucose levels are low. So again, Hunter, when you go on the show Naked and Afraid, and you have nothing to eat, okay, pretty soon you're going to become hypoglycemic. That's when you start releasing your glucagon. Okay? And glucagon is released by the alpha cells. And what does glucagon do? It stimulates glycogenolysis, for one. It stimulates the breakdown of glycogen into glucose, which can then serve as a fuel for the next 12 to 24 hours. But again, you have a limited supply of glycogen. It will also begin to stimulate gluconeogenesis. So certain amino acids can be converted to glucose. Okay? We said that glycerol can be converted to glucose. Okay. So and what's going to happen is, as fat is being broken down because we don't have any more glucose, then as that fat is broken down into glycerol and fatty acids, the glucagon is favoring conversion of that glycerol to glucose. Right, because early on the brain needs glucose. Okay. So glycogenolysis and gluconeogenesis serve to maintain glucose levels. Okay. It serves to bring back glucose in the face of hypoglycemia. Okay. Now, glucagon also stimulates fat breakdown. Okay. Why? Because we don't have any glucose. We're hypoglycemic, so it stimulates fat breakdown. So then fatty acids are released into the bloodstream. Okay. And we said that most tissue in times of need are capable of breaking down fat. Okay. And so fat can be used as an alternative source of fuel. All right. Now let's talk briefly about the vitamins. Except, if you lived in England, we'd call these vitamins. Okay? If you're good, you'll be able to recognize that, oh, it's the same word. Okay.
Yeah, it's funny, I exactly right, just to say aluminum, like aluminum.
Yeah. I like to hear him talk.
Yeah.
I know students enjoy hearing him talk. They don't enjoy hearing him teach, but they enjoy hearing him talk. I know that. These are organic. What do I mean by organic substances? What's that? Well, organic, they are found in nature, but organic means that they have a carbon backbone. Okay? So these molecules have a carbon backbone. And the thing is that they're essential to normal metabolism, but we only need very, very tiny amounts of vitamins in order to function normally. So it's not like carbohydrates or lipids or proteins where we need to eat massive amounts. Compared to those other major nutrients, we eat very little. And the vitamins that we take in our diet are classified as either water-soluble or fat-soluble. Okay? Generally, most water-soluble vitamins are peed off. We don't store them, with one or two exceptions. Whereas fat-soluble vitamins tend to be stored. Now, your fat-soluble vitamins are which ones? Do you know?
K, E, A, and D.
That's it. A, D, E, and K. Okay? Now, there can be a potential problem with the fact that we store fat-soluble vitamins. You'll see an occasional individual who will suddenly develop an interest in, for instance, bodybuilding. Sometimes it's a teenager. Okay? And so they'll go to the drugstore and get lots of vitamins and muscle supplements like creatine. Okay? And if they're purchasing fat-soluble vitamins, and they're taking probably excessive amounts, over time, those fat-soluble vitamins can build up in the body and actually cause a disease. It's called a hypervitaminosis. A hypervitaminosis. So you can get a disorder from too much vitamins. Now, that generally doesn't happen with the water-soluble, but more likely with the fat-soluble. The reason they're called fat-soluble vitamins, by the way, is their absorption depends upon the absorption of fat. So, for that patient who has steatorrhea, you remember what steatorrhea means?
Fatty stools.
Right, fatty stools, fat malabsorption. It could be because they have an obstructed common bile duct. Okay? Or it could be because they have a malignancy in the head of the pancreas. And so lipase can't reach the duodenum. It's obstructing the pancreatic duct. Whatever the reason, if they can't absorb fat, then they can't absorb fat-soluble vitamins, A, D, E, and K. And so if you can't absorb vitamin K, what happens? Vitamin K is used for what? Production of certain clotting factors, 2, 7, 9, and 10.
Oh, yeah.
Okay, so then you develop a hypocoagulable state. You develop easy bruisability or bleeding. Okay. If you can't form vitamin D, what happens? Over a long period of time, you can develop osteomalacia, which means softening of the bones. Why? Because vitamin D is necessary for absorption of calcium from the gut. Okay. So the fat-soluble vitamins are dependent upon fat absorption. Not the case for the water-soluble vitamins. Okay. Now, because only minute amounts of water-soluble vitamins are needed, okay, and are stored. Remember, we don't tend to store water-soluble vitamins. Any water-soluble vitamins present in excess of what we need simply gets peed off. Okay. Generally, water-soluble molecules, if they're small enough, are freely filtered in the kidney. You know, a lot of old people are used to seeing a primary care physician, and if they complain of fatigue, they get some vitamin B12. It's a water-soluble vitamin. Okay, and the truth is that they're probably not B12 deficient, and when you give them the B12, they're probably just going to pee it off. But I had to practice, you know, because so many people would come, oh, I need a shot of B12, that I realized it had placebo effect. And so I started using it. Okay, not that I believe that it does anything, but the beautiful thing about B12, number one, it's very cheap. It's not expensive. You can get it from, you know, pharmacy rather. And the nice thing is it comes in a nice red color. So when you draw it up into a syringe like a cc of B12, it's got a nice red color. Okay? And then when you inject it into a muscle, it's a little bit painful. Okay, which is a good thing because the patients associate with pain and discomfort with the fact that, okay, it's going to do some stuff. Okay? And so I had patients that were chronic symptoms of fatigue, and they would come in once a month. They wanted their B12 shot because they felt certain that after they got that B12 shot, it gave them a little boost. Now, I knew they were just going to pee it right off. Okay? But does it make any difference? If it makes them feel better, if it has a placebo effect, then that's our job, to make patients feel better. So in the beginning, I remember when I was a young physician, I was very reticent to do that. I just didn't believe in it. But I soon realized over time that these were patients, many of whom really believed in B12 and thought it made them feel better. So if you think it's making you feel better, why not go for it? You know? Or sometimes, yes?
Don't people go and get the vitamin B12 shots to lose weight?
You know, here's the thing. They do, and again, I'm not sure that really does anything. The electron transport system, have you taken any biochemistry? Okay. You remember that when glucose is broken down in the Krebs cycle, okay, you form free hydrogen, which carries an electron, which gets then attached to an electron carrier. Okay, and then that electron carrier then transports the electron through a series of cytochromes. Okay, in other words, that electron gets carried from point A to point B to point C to point D. At some point, it's going to be used to generate energy, ATP. Well, one of those electron carriers is really made up of B12. So the thought being, I guess, is that because those cytochromes are composed, or one of them is composed in part of B12, that if you give someone B12, you're assisting with the development of ATP. That's kind of the underlying theory. Okay. But again, I'm not, I'm just not a big believer. But I do use it because people believe in it. It's like if you have a patient who's very, very religious. It doesn't matter what religion it is. They can believe in Buddha. Okay? If that helps them to survive cancer, I support it. I'll say a prayer to Buddha with them at bedside. Okay? If that's what they believe. Okay? Because that's part of their support. That's part of, what's going to make them feel better or cope better. Another one I used a lot was niacin. Niacin can actually have some therapeutic benefit in that it can lower lipid levels in the blood. But the thing about niacin when you inject it is that it causes your ears to get red. It causes vasodilation on the ears, and it can cause kind of a numbness. And it can even raise your heart just a little bit. And so sometimes, if a patient is just kind of, there's a term we use for this, they're really perfectly fine, but they have a lot of kind of symptoms, you can give them niacin. And because it causes the flushing, it causes a little bit of itching, it has all, they start to feel stuff. They feel like, oh, it's doing something to my body. It's making me better. So sometimes you use drugs, or you use particularly vitamins, because niacin's a vitamin, more for its placebo effect, knowing that we'll just compete off. But if it makes them think they're getting better, then maybe it's okay.
Well, no, we can't do that. And then, oh, we use some vitamin. Oh, I know it's not good.
Well, and for patients who have chronic pain, sometimes you get placebo in the hospital. They call it normalsaline. It's a placebo. Normalsaline is really normal saline. But if you pronounce it differently, you'll say the patient's complaining they want something for pain again. So you say, okay, give them 5 cc's of normalsaline. Well, all nurses know that you're saying 5 cc's of normal saline. Is it really going to do anything? No, but the patient all of a sudden...
Might hydrate them, right?
Oh, 5 cc's isn't going to hydrate too much, but...
That's funny.
Okay. And then finally, minerals. So, the body requires moderate amounts of 7 minerals: calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium, all of which are necessary, it says here, for a smoothly functioning system. All of these minerals have specific roles in the body that are important beyond the obvious. For instance, calcium. We know that calcium is necessary for strong bones. Okay? It calcifies that matrix that's used in the bones. But calcium has other roles. You know that the clotting cascade, almost each step of the clotting cascade requires calcium. So for normal coagulation, you need calcium. Muscle cells, in order for them to contract, calcium has to be released into the sarcoplasm. Do you all remember that it binds to troponin, displaces tropomyosin? Remember that? Mm-hmm. And that leads to cross-bridge formation. Okay? The same thing is true with almost all these. Potassium. Okay, sodium. Sodium and potassium are very important in generation of action potentials. Now, action potentials are these electrical impulses that are generated by muscle cells and nerve cells. So muscle function and nerve function depend upon these minerals. Sulfur. Sulfur, is a key component of the extracellular matrix of cartilage. Chondroitin sulfate it becomes part of the extracellular matrix of bone. So if people have degenerative arthritis and they want to build new bone, they can take supplements that contain chondroitin sulfate, which builds the extracellular matrix. Okay. So each of these minerals is necessary for what I like to call just smooth functioning. They all have important roles. All right. So that wasn't too bad, huh?
No.
You knew a lot of that already from A&P 1, huh? Or if you took nutrition, or if you took biochemistry. This was the biology version. This is the dumbed down version. But that's all right. Now, let's do something here. We're going to go on a little field trip. We're going to go on a field trip. Let's close this door. I don't want people coming in and out of lab stuff. All right, let's go on a field trip to this next room.
That's very positive.